So I want to tell you about the mathematical journey I went on after my first encounter with this problem. This is a problem about two intersecting circles. To explain the premise, let's introduce a couple of terms. Let's call a line segment AB through one of the intersection points P a combined chord because both AP and PB are chords of the respective circles. Let's define the split product of a combined chord AB to be the product of the lengths of the two chords. This problem is about finding the combined chord through P with the largest split product. So I tried drawing a few, starting with the ones that give the smallest split product I can think of. If you tilt the combined chord all the way down until it connects the two intersection points, one of the chords in the combined chord goes away, making the product 0. If you tilt it the other way, eventually the same thing happens on the other side. Then I tried drawing some in the middle, like this one that goes through the center of one circle and its counterpart. If the circles were the same size, these two lines would be identical, with the same chord lengths and the same angles, and therefore, of course, the same split product. Surprisingly, even if the two circles were different sizes, they'd still have the same split product, despite the chord lengths all being different. Here's the proof using similar triangles. So there are two combined chords with a split product of 0, sort of, and there are two combined chords with the same split product here. Does that mean all combined chords come in pairs that have the same split product? If we draw any arbitrary combined chord, can we find the other one with the same split product? Remember earlier, with the combined chords that go through the center of each circle, we were able to get this pair of similar triangles because both of these angles were drawn on the diameters of a circle. Now for an arbitrary combined chord, we can make sure these angles are the same by doing something similar, making sure they cut through the same proportion of their own circle. And how do we do that? Well, the usual way when we want to talk about the proportion of a circle, with the central angles. All we have to do is to make sure the second combined chord makes the same central angle in the second circle as the first combined chord makes in the first circle. These angles will be the same because they're inscribed angles made on the same proportion of a circle, and these triangles will be similar. From there, the same logic applies as before, and we get that the two combined chords have the same split product. This leads to a special case where we cannot draw another combined chord with the same split product, namely if the combined chord makes the same central angle in both circles. What's more, this special case happens to be the combined chord with the largest split product that we were looking for with the original problem. Math makes sense again. Now the problem becomes, is the special case also the longest combined chord in a given pair of intersecting circles? Let me know what you think in the comments below, and until next time, stay curious.